this video, we're going to look at 11.5, area of circles and sectors. So we're to theorem 11.9, which is the area of the circle. And of course, the area of a circle is pi times the square of the radius. So you all know this as pi r squared. Now, since we're back to doing area, we're going to have square units. And I need you to look at this circle now. Do you notice how this circle is now shaded? So now it says find the indicated measure using the formula for the area of a circle. Now it's going to ask us different things every problem, so we have to pay attention to what exactly we are finding. So the first one is the easy one. It just says area equals, so we're going to do pi 4.2 squared. So of course the calculator will do that for us. So if I'm using the calculator for this one, I would just say 4.2 squared. So it's 17.64. If it wanted an exact answer, we would leave it like that, but it doesn't tell us to do exact, so we're going to say times the pi. So the area is approximately 55.4 square meters. Now the next one, if you'll notice, it's asking us for the diameter, and this time it tells us the area. So for this one, we're going to say 201 equals pi r squared. We have to get the r squared by itself, so we're going to divide by pi. Again, we're going to need the calculator to help us do that. So 201 divided by pi. Now that's going to give us roughly 64. So I'm going to write this down like this. But we've got an r squared there. So if we square root both sides, and if we know that was 64, we know it's going to be about 8. So we're going to round this answer. So 8 equals the radius, but it's asking for the diameter. So the diameter for this one is going to be 16 inches, since this is inches squared. Now, this next picture here, notice it went back shaded. It says area again, but this time they gave us a diameter. So instead of using 9, we are going to say 4.5 squared, and we're going to just use the calculator again. So this one is going to be pi times 4.5 squared. So we're going to get approximately 63.6 centimeters squared. And then number 4 says find the radius. So 154 is the area equals pi r squared. So we can do all of this on the calculator. So we can say 154 divided by pi. That again about 49. So if we square root that 49, we're going to get the radius of about 7. So that's just a review of the area formula. You just need to make sure that you are paying attention to what they are asking you. Now we're going to look at the definition of a sector of a circle. It is the region bounded by 2 radii of the circle and the intercepted arc. So I have drawn a circle here. Here is the 2 radii, and I want you to notice that there's 2 sectors in this picture. There is the piece that I have colored pink, and then there's the piece that I have colored yellow. So the sector of the circle is the part that is highlighted. So up here, all of this is the area. So now you will be asked to find the area of the sectors of the circle. So that's going to lead us to theorem 11.10, the area of a sector. So here is a good picture. They have shaded just one portion of the circle. And again, this is going to be dealing with the ratio of areas of the sector to the whole circle, which in this case pi r squared, is going to be equal to the ratio of the measure of the intercepted arc to the whole arc. So looking at this picture, you have the arc of the sector APB, okay, over the area of the circle, so shaded to the whole circle, just like the measure of the arc, so the measure of AB is to 360 degrees. Now we did this with arc length where we did the circumference. So this changes now because now we have moved inside to area. So part of the area, the sector, to the whole area, pi r squared, part of the degrees over the whole degrees. So let's look at some examples here. Number 1 says find the area of the shaded sector RQS. Now, we need to set up our proportion, and we are looking for the part that is shaded, so the sector. So I'm going to call that X, over the area, so pi radius squared equals the degree of the arc, 63, because that's the central angle, over 360 degrees. So we basically just have on our hands again a proportion. So if I cross multiply, I get 360x equals. Now, I'm going to let the calculator do this work, but I know this is 25 pi. So what I'm going to do is I'm going to say 63 times 25, and that is going to get me this number pi. That is a lot easier to write down than to write down actually all of these decimals. So that's too hard to write down. But that is that part. So I'm going to divide by 360 to solve for x. Okay? So x is approximately 13.7 square units, since they did not give us any units. Now, if it wanted you to leave that as an exact answer, you would simply say math fraction, and you could say x equals 35 over 8 pi units squared, if it wanted an exact. But on this problem, it did not ask us that. Now, a very similar problem to this is number 2. It just says find the area of the shaded sector. Nothing is labeled. So you're going to do part whole, part whole. So, part that's shaded to the area, so pi r squared is going to be 144 pi, equals central angle 149, so that arc is going to be 149 to 360. Since it does not tell me to do exact, I'm going to let the calculator do all of the work. So 149 times 144 pi, divide that by 360. The area of the sector is approximately 187.2, in this case, meters square, since it is noted in the figure. Now, question 3 and 4 is not going to ask us to do the area of the sector, but it's going to ask us to find what they're asking for. So here, they're telling us the area of the shaded sector, and they're asking us to find the diameter. So really what we need to find is the radius, since we have the area. So we have part of the area at 20.89 square feet over the area, pi r squared. Since I'm looking for the diameter, I need to use the formula. Is equal to, now this is 78 degrees. I need to know this degree, so this major arc. We know the minor arc. So we are going to have to say 360 subtract 78, and that's going to give us 282 for that major arc over 360 degrees. Now, for this one, we're going to go 20.89 times 360, okay? And then that is going to be divided by, so let's write this out. We have 282 pi r squared equals this number. So to get the r by itself, we need to divide by 282 pi on both sides. Now, again, use parentheses so your calculator will be forced to do order of operations. Now, that equals r squared, but we need to know what r is. So I'm going to write down 4 digits here so I don't have any round off error, but I'm going to let the calculator do that work for us. So the radius is approximately 2.9. Now, the problem wants diameter, so we're going to multiply that by 2. So we're going to say that the diameter is approximately 5.8 feet. So there was quite a bit more work involved in that one, but the calculator does it for you if you set your proportion up accurately. Now, question 4 is asking us something else. Question 4 is actually asking us the area of the entire circle. So we're going to set this one up a little bit, in my opinion, easier than question 3. Here we were looking for a piece of the area. Over here we are looking for the whole area. So I'm going to put an A there for area. Now I know the part of the area is 22 square meters. I know the part of the degree, and I know 360. So now I can cross multiply, do this work on the calculator. So 360 times 22, and then I'm going to divide that by 45, and that's going to give me the entire area is 176 square meters. So since this one asks us for the bigger piece, we did not have to use pi r squared. Now I have flipped it over to the back of our notes, and we're going to do a quick word problem. It says a contractor needs to cut a section out of a rectangular piece of wood as shown. To the nearest square inch, what is the area of the remaining wood? Now, the first thing I want you to do is look at this picture. Everything is shaded except this little shape here and the semicircle. So what we're going to do, we're going to come up with a plan. If we find the area of the entire rectangle here and we subtract out the area of this square and the area of the semicircle, then we can quickly find the area of this piece of wood. So the area of the whole thing is simply 11 times 7, which is 77. The area of this in here, that's 3 inches. 3 times 3 is 9. And to get the area of this semicircle, we're going to do the diameter half, 1.5, so the area cut in half. And when you do all of that, it just simply comes out to be 64 square inches. So coming up and writing a little plan here, we'll take problems like this. We call these composite figures, just a little bit more easier for you. Now, just like with our last lesson, we had to shift into radians. So it says dealing with radians. So now remember, we are finding the sector area of a circle. The problem is what happens when the circle does not give us a degree, but it gives us a radian, which we call theta. Well, it's simple. We still do the same thing. We still do part. We still do whole, area. We still do part. And we still do whole, except now these are in radians. So I don't want you to be confused. It's just going to switch measures on us. So question 6 says, find the area of the sector formed by central angle of 1.4 radians in a circle with a radius of 2.1 meters. So we're just going to draw our proportion, and we're going to say, okay, we're looking for the sector, x, over the whole area, pi radius squared, equals the measure, 1.4 radians, so remember this is in radians, over a whole circle. Remember there's 2 pi radians. So these are now the same unit. Okay, now I have written out, I cross multiplied, so I have 2 pi x equals, and you can see on my calculator over here, that I have that, only I left the pi's in there. Now the reason why sometimes we leave the pi's in there, because you can see right here, this pi and this pi will cancel out. So this cancels out to leave x, so I just have this number over here divided by 2. Now the calculator will of course do the pi's for you, but if you're using a calculator that's not very easy to use, that's a little trick you can use. So the area of the sector with this information would be about 3.087 square meters. So it's the same thing, it's just dealing with the radian. Now we're going to finish this set of notes out with question 7. And it says the diameter of a circle is 26 centimeters. If the angle of the sector is 7 pi divided by 12 radian, what is the area of the sector? Now, we are going to try to simplify as much as we can in dealing with this problem. we are looking for the area of the sector, which we are going to call x. We need to know the whole area of this. So if this diameter is 26, we're going to say pi r squared. So we're going to use 13 squared there. Now, this is where it gets a little weird. So it's 7/12 pi radians over 2 pi. Now, the first thing that I want you to realize that you are allowed to do, you are allowed to simplify this by getting rid of those pi's right there. So that is a legal move. Now that we know that, we now have cross multiply. 2x equals 7/12 times pi times, I'm going to go ahead and say that's 169. So basically what we need to do is to calculate this on the calculator and divide it by 2 to solve for x. So we have 7/12, we have that. Then we have that times pi times 169. So that's going to give me that number. Then I'm going to divide that by 2. And then I'm going to get the answer. So the answer to this, the area of the sector, x is approximately 154.85 square centimeters. Now, if you printed the notes out, you'll see that there's more problems on there, but I'm just going to go ahead and end the video there because you all get the hang of this. It is part of the area for the sector, the whole area, part degree or part radian over whole degree or whole radian. So that wraps up section 11.5.